So in this video, we'll be learning about reduced row echelon form, which is also known as RREF. Now it is quite similar to REF, and I would suggest that you would learn about REF. I have made a video on it. So the conditions of REF is that each pivot can be any digit and you cannot have ones below it. Now RREF is the same except that it states that each pivot has to be one. It has to be exactly one. It cannot be any digit like 3 or 2 or negative 2, which is allowed in REF, but here in RREF it has to be 1 and you cannot have any digits below it. So by any digit I mean non-zero digits, anything except 0. So you cannot have uh, 1 below it, any digit below it and above it basically. And here let's do an example. So here our first pivot in our first row is going to be 1, and now we look down if we have any non-zero elements. Here we have 0, so that's fine. So now moving on to the next row, we have the next element here or next pivot to be 1, and again we check if we have any digit below it or above it except 0. So here we have 0 here below it and above it. So this is in R, oops, RREF. Now let's say if this 0 was, let's say, 3, then this is in REF, since REF allows digits above it but not below it. So in our example, it is a 0, so it's an RREF. Now moving on to the next question, we notice that we have a 3 as our first pivot. So automatically we know that this is not an RREF since each pivot has to be 1 here. Now moving on, let's check the second row. So diagonally and then to the right, so down and right, and we don't have any digits below it, so that's good. 0 and 0. So next pivot is 1 in our second row, and then we don't have any digits above it and below it, only zeros, and then our last pivot is 1 here. So this is in REF since we have a 3 here. Now if this 3 was a 1, then this is an RREF. And now let's say we have instead of a 0 below the 3, we have a 1. So this is neither in REF or RREF since this 1 violates both of RREF and REF. So anyways, we have a 0 here. Let me bring that back. Just keep that in mind. You cannot have any digits below the pivots basically. So now our next matrix, we have a 1 here, and we don't have any non-zero elements below it, only a 0. And then our next pivot in our next row is the first non-zero element, which is going to be 1, right? And we don't have any digits below it and above it except a 0, right? So this is in RREF, and we ignore anything to the right since that's it, right? All we care about is the pivots and zeros below it and above it. Our next example here, we have the first pivot to be 1 here, and then we don't have any digits below it, only zeros again, so this is fine. Now down and to the right, so our next row has the first non-zero element of 1 here, right? And again, we don't have any digits, non-zero digits below it and above it, so that's also fine. And our last row, we have a 0 row, right? So that's it. These are the two pivots, and this is in REF. Now moving on again, so I'm gonna quickly do this. So 1 here, and then no zeros, non-zeros elements below it, and then here, and we have another non-zero, so this is also in RREF. And in our last matrix, we have the first row pivot to be 1, and it's in the third column, right? So we notice that we don't have any non-zero elements below it, and we have two 0 rows, so this is also in RREF since nothing is violating the rules here. So now let's see how we can convert a matrix into a RREF form. So let's say we have the matrix as 3, 2, 4, 1, and then 1, negative 1, 0, negative 1, and then 0, 0, 4, 0. And we want to convert this into our REF, right? And first of all, we notice that, in the first row, we have the first non-zero element to be 3. And we need each pivot in our REF to be 1. So the first operation that we can do is we can switch row 2, as it has a 1 here. It will make our life very simple, right? So if we have a 1 on the top, we can use it to get rid of any numbers below it, right? So we can do like minus 3r1 plus r2 to get rid of this 3, and we need zeros below the 1 also. So here what I'm going to do is I'm going to switch r1 by r2, and we can do that, and we are left with 1, negative 1, 0, negative 1. Everything else is the same. And then we have 3, 2, 4, 1, 0, 0, 4, 0. And I'm sorry about my handwriting, I'm just writing it quickly. Now we can use r1 row 1 to get rid of this 3 below it, since we cannot have any digits below the pivot, right? And this is our first pivot, by the way. So here what I'm going to do, I'm going to do minus 3r1 plus r2, and I'm going to write the matrix over here. So the first row stays the same. We're not doing anything to that, we only making change to r2, row 2. So minus 1 minus 1, 0, minus 1, and then 0. And now this is going to be 5, 4, and 4. This is just normal algebra, or plus minus. So I'm not going to go too much detail in this. So basically what I did here is minus 3 times negative 1, which is 3, plus r2, which is 2. So 3 plus 2 is 5, and then so on for the others. So, and the last row stays the same. Now we notice that we have the first pivot to be 1, and if we look down and to the right, in the second row, the first non-zero element is 5. So this is our second pivot, but we need this to be 1 exactly. We cannot have any other number as our pivot. So what I'm going to do for row 2 now is I'm going to divide row 2 and row 3 actually by 1, this r2 by 5 and r3 by 4, since we need these pivots to be exactly 1. So here I'm going to do 1 over 5 r2, and then 1 over 4 r3, right? And then we are going to be left with, first row stays the same now, and then we have 0, 1, 4 over 5. 4 divided by 5 is 4 over 5, and then 4 over 5 again, and then the last one is just 0, 0, 1, 0. So now we have all our pivots to be 1, so that's fine, and we don't have any digits below it. Now let's look above it. We need to get rid of the digits above this pivot, which is minus 1, and this pivot, which is 4 over 5, right? Since the rule says in RREF that you cannot have any digits below the pivots and above. In REF, it's that you cannot have anything below it, but you can have anything above it. So this is an REF right now. So to convert it into RREF, we are going to do r2 plus r1 to get rid of this minus 1 above this one, and then I'm going to do, or let's just do this first, not to complicate too much. So it's going to be left, I'm going to be left with 1, 0, and then here is going to be 4 over 5, and then minus 1 over 5, right? Yeah. And then we have 0, 1, 4 over 5, 4 over 5, and then we have 0, 0, 1, 0. Now again, we have our pivots to be these ones, and now we need to get rid of this 4 over 5 above this pivot and this 4 over 5 also. So to do that, we can do the following operations, which are minus 4 over 5 r3 plus R1 to get rid of the first 4 over 5 in the first row, and then the same minus 4 over 5 R2, or sorry, R3 plus R2. And this will give us the final answer to be 1 0 0 0 1 0 and then 0 1, sorry, 0 1, and here we are left with 1 over 5, negative 1 over 5, sorry, 4 over 5 and 0. Oh, let me just write this again, I'm sorry. So again 1 0 0, then negative 1 over 5, and then we have 0 1 0, 4 over 5, and then we have 0 0 1 0. And if we look at this now, we have the pivots to be 1 here, 1 here, and 1 here, and we don't have any digits above it and below it, right? And this is in RREF. So let's do another example. Let's say we have the matrix to be 2 8 4 2, and then 2 5 1 5. Okay, let me just write it again. So this is what we have the matrix as, and we want to convert this into RREF. So first step again is look at the first row, and we need a 1 in the first pivot. So we have the first pivot to be 2 here, and we need to somehow convert this into a 1. And let's say we had the order to be 5, the second row first, and then the first row as the second. You notice that if we divide the row right now that we have 2 8 4 2, we are going to be left with 1 4 2 1, right? And if we have this and we divide this by 2, we're going to be left with fractions. So it's always better to be having whole numbers and not fractions. So here what we can do, if this was the question, we could have quickly first switch the two rows, row 1 by row 2, and then divide the row 1 by 2. So here what we're going to be left with is just 1 over 2. The row operation is 1 over 2 R1, and everything else stays the same. Now let's get rid of these pivots, or these digits below these pivots, which are 2 and 4. So the operations are going to be minus R2, minus 2R1, sorry, plus R2, and then minus 4R1 plus R3. And we are going to be left with, the first row is going to stay the same. The second row is going to be 0, minus 3, and then 3, and then we have 0, minus 6, minus 9, and then 3, or sorry, negative 3. So now we notice that we are done with the first pivot, and we don't have any zeros below it. So let me actually do that. Yeah. Now moving on to the second pivot, we have it as negative 3, right? And we somehow need to convert this into a 1. So what can we do here? We can do the operation of minus 1 over 3 or 2 to convert this minus 3 into 1, right? And we always need the pivot to be 1. So here I'm going to be left with is 1 4 2 1, and then 0 1 1 negative 1, and then we have 0 minus 6 minus 9, and minus 3 is going to stay the same. Now we need to get rid of this minus 6 below this 1 pivot and 4 here. So we can do the operation as minus 4 R2 plus R1, and then 6 R2 plus R3 here, right? Then we are going to be left with 1 0 minus 2 5, and then we have 0 1 1, negative 1, and then we have 0, 0, minus 3, minus 9, sorry. So now we are done with the second pivot and we don't have any digits above it and below it. Now our next pivot is going to be minus 3 here. So we need to convert this into, again, 1. So here we can do, again, the same step, minus 1 over 3 or 3, right? And then we are going to be left with, first two pivots are going to stay the same. 1, 1, minus 1, and then we have 0, 0, 1, 3. And our last step here is to get rid of these digits above the third pivot, right? And we can do that by doing minus R3 plus R2, and then we have 2R3, oh yeah, 2R3 plus R1, and the final answer would be 1, 0, 0, 11, and then we have 0, 1, 0, minus 4, and 0, 0, 1, 3, and that is the final answer. And again, let's recheck. First pivot is 1, second pivot is also 1, and then third pivot is also 1, and we don't have any digits above it and below it, any non-zero digits, sorry. And that's all for this video. I hope that you understood this. If you have any questions, you can always ask in the comment section. I'll be more than happy to answer. And thanks for watching. So I just tried something on my calculator and I do have a shortcut method for you guys. So from this matrix that you're given, you can type this on your calculator and somehow get that x is equal to 11 and y is equal to 4. Oh, sorry. So x is equal to negative 11 and y is equal to 4 and z is equal to minus 3. And I will be making a short video on how to do that on the calculator. So stay tuned for that and I'll be making that shortly. So you can use this method to recheck your answer, find the final answer, since you have so many calculations over here and one silly mistake or small mistake can completely change the final answer.